lecture series of operating system. In this lecture video, we are going to see about one case study on process states. So before going into the real-time example of process states, first I will explain what is the process states. So every process have a different states. From the starting to end of the process. So the process states are classified into the five different steps. First we have a new state. In the new state the process is created, then it go to the ready state. In the ready state the processes are in the queue, ready to execute. In the ready state the processes are ready to execute and waiting for the CPU execution. Then next we will having the running state. The running state is the execution state. From the ready state the processes are pick up and go to the running state. So next one is a waiting state. In the waiting state the processes are waiting for some external events will occur. Suppose if any process is required the IO devices, means that could be waiting in the waiting state. After the waiting state it goes to the ready, and from the ready it goes to the running. So final state is a terminated. Once the process is completed is execution, and also the execution time is over, means that go to the terminated state. So this is the five states of every process we will have, that is a new, ready, running, and waiting, and terminated. Now our student will explain what is the process and what is the process states, why these states are very important for any process creation and process termination.
Good morning everyone. Today we are going to talk about process states and process creation. States, there are five types. There are new, ready, running, waiting, and terminate. New stage, the process was created in new stage, and then in ready state the process was in ready queue so that it can be executed in CPU. And in running stage the process was being executed, and in waiting stage it is waiting for an event to complete so that this process can continue its process. And the last stage is terminate. So terminate is after completing the process it will remove from the program. So the process will be taken. So the next one is process states diagram. There is a 5 stages in process states. That is new, ready, running, terminate, and waiting. Firstly, we going to create a new process, and that process is admitted to a ready queue. Every process is stored in a ready queue, and the dispatch is used to transfer the process in ready queue to running state. In this running state, the CPU will execute the processor. Once the process is complete, it will go to the terminate stage. All the processors exit in terminate state. If any interrupt or IO request hires in the processor, it will go to the waiting state. Once the interrupt or IO request is completed, it again goes to the ready queue and waiting for the running state of the. Now let's see about operation on a process. So there are two types, process creation and process termination. Now let's see process creation. So when the fork system is called, the parent will be moved to waiting stage, so that the child process will be executed. After completing the child process, it will initiate waiting process, so that the parent process will be resumed and repeated. So the next one is process termination. Process termination is containing the major two types. The first one is terminating the parent process, and then the child process also terminated by using the parent process. Another one is cascading termination. Cascading termination means the thread processor are terminated firstly, and then it goes to the process and delete the process. And now let's see process scheduling. So in process scheduling there are three types: long-term scheduler, short-term scheduler, and medium scheduler. So now let's say about long-term scheduler. So there is a job pool. Job pool to ready queue memory is called long-term scheduler, and ready queue to CPU is called short-term scheduler. So when the process is created, it will be waited in waiting stage. After dispatching that process, it will move to CPU. So in CPU, if it requests for IO interrupt, after completing that IO interrupt, it will again move to ready queue. So if it's called time bound, after completing the time bound process, it will again go to ready queue. So it may also call child process. So the child process will be called through fork system call. So after completing the child process, it will again move to ready queue. So job pool is also called secondary memory, and ready queue is also process states. Currently the state of the process, it will waiting in ready queue or some or in the terminated queue, where the process is waiting in a process state, and the process number. Every process has a unique ID.